I believe that one of the absolute best examples of science leading to solutions right here at home is the work that's happening along the Pájaro River in South County. You may recall that in early 2023, the levee along that river breached and it flooded the town of Pájaro in a pretty catastrophic way. The good news is that we have an extraordinary team of people who are working to rebuild and improve that levee. Some of the solutions would reduce the risk of flooding happening again. They would also recharge freshwater aquifers and improve some of the habitat along that river. One of the people on that team is Andrew Fisher. He is a distinguished professor of Earth and Planetary Sciences at UC Santa Cruz, and he studies hydrogeology, which is essentially the study of water in and on the Earth. Andrew is my guest on today's episode of Science Solutions Santa Cruz. I'm Jonathan Hicken. Enjoy. In the studio today, I have Andrew Fisher, Distinguished Professor of Earth and Planetary Sciences at UC Santa Cruz, and a big focus of his is hydrogeology. Good to see you, Andy.
Yeah, good to see you, Jonathan. Happy to be here.
Thanks for being here. All right, so today we're mostly going to be talking about the Pájaro River and water management in South County here, but I was doing a little research, and I understand you started your career kind of looking at deep sea hydrogeology. Is that correct?
Yeah, that's right. I was an undergraduate geology major, and around that time in the early 80s was after plate tectonics had been figured out, but people were discovering these vent sites on the seafloor where hot water was coming out, and there were all these strange organisms. And that drew me to a graduate program in oceanographic geology and geophysics. And so I learned about how water interacts with rocks and sediment by studying it on the bottom of the ocean. That was my introduction.
And so how did you eventually kind of make your way on land to be looking at sort of the water that's under the soil that we're standing on now?
As I was learning about hydrogeology in the seafloor, I inevitably came across papers and textbooks, and a lot of the focus was on freshwater, was for water resources, water on land. And like a lot of geology majors, I'd spent time outdoors and I enjoyed rivers and wetland areas. And I think in my mind, I'd always wanted to find a way to bring those interests together. And when I arrived at Santa Cruz in the mid-1990s, well, even before that, when I was a researcher at Indiana University, before I came here, I got involved in groundwater work. At that time, I was really making that pivot towards freshwater systems. It was also an interest in having a broader portfolio of opportunities because given the nature of funding, the interests that students have, often they're in very practical topics. It just seemed like a good idea to have interests in a couple of different areas. And inevitably, the research brought me to topics where there were connections. So when I arrived here, I really made a strong effort to continue that pivot, but also maintain some activity in the deep sea. So I was pretty active early on here with oceanographic expeditions. And since, including my time here and time in graduate school, I've probably spent maybe 4 years at sea.
Wow, no, like cumulatively.
Yeah.
Dang, that's a lot.
Yeah, it was a lot for a while, and I don't go out as often anymore, but for a period I was going out pretty frequently.
Well, I'm rewinding now to early 2023.
Yeah.
When the news broke that the Pájaro River levee had breached, and that kickstarted a ton of community interest and a lot of work. You have been central in that project. How had you already been working on Pájaro River issues or local issues, or did that event kind of spur you to get involved?
I'd been involved for quite a while, but let me back up one step,
Please.
Which is just to note that the Pájaro River, like the San Lorenzo River in Santa Cruz, has been flooding for decades, many decades, and both rivers have levees. These are sort of artificial walls or sloped mounds on either side of the river, and the goal of levees in many cases that are added to rivers is to allow more flow to occur without flooding. People tend to build close to rivers, close to waterways, and that puts us in harm's way. So both of these systems had been modified back in the mid 20th century with new levees, and levees were raised, levees were reinforced, and all of that was to protect people, businesses, farmland. Again, in downtown Santa Cruz, downtown Watsonville, the community of Pájaro across the river from Watsonville. And the levees on the Pájaro River have breached a couple of times in the past. It's not the first time. And there's been interest in making the levees stronger around the river, along the river, but also increasing the capacity of the river to handle bigger flows. A lot of times when levees are built, one of the targets that's commonly chosen is to be able to carry what's called a 100-year flood event. This was an event that on average will come about once every 100 years. It's not on a schedule, but just based on the flows, what do we expect might occur about once every 100 years? And as of the time that the levee on the Pájaro River breached in 2023, the Army Corps had estimated that that channel was ready for about an 8-year storm, not a 100-year storm.
And the Army Corps, this is the Army Corps of Engineers, right? And this is the body that manages.
That's right. Within the United States, the U.S. Army Corps of Engineers is the federal agency that is most engaged, most responsible for reducing flood risk, for helping communities who live along river systems, other water bodies that flood, to manage that water, to provide an extra margin of safety. So in the case of the Pájaro River, those levees were put up, by the Corps, typically with coordination, collaboration with locals. And so there had been an effort underway for decades to improve the levees. I'm a latecomer to the party.
Okay.
And many people have just put in so much work, hours and hours, studies, analyses, computer models, working with the Army Corps, working with the counties. County of Santa Cruz is mostly to the north of the river, County of Monterey mostly to the south in the lower part of the Pájaro River. But that river goes all the way up through a piece of San Benito County, up into Santa Clara. It's got a 2,600 square kilometer watershed. So we're seeing sort of the end of that river system. And a lot of folks have been trying to work with that river system for decades. And what happened was that the state of California really stepped up, because in order for the Army Corps to take on a big project like this, there needs to be local or state funding for part of it.
Like a match kind of thing.
Kind of a match.
The community needs to put some skin in the game.
That's
basically.
right.
Okay.
That's right.
Okay.
And around the lower Pájaro River, particularly on the south side of the river, the community of Pájaro is a disadvantaged community. It's not a wealthy community. And coming up with that local money is really challenging. Even once it's all built out, there's going to need to be maintenance. And that's really important. Part of the challenge with the levees has been maintenance over the decades, in addition to the channel filling in with sediment or vegetation, which lowers its capacity. So there's a lot, and then we just have climate change, which is resulting in many cases with more intense rain events, more intense runoff. Even without the average rainfall in a year changing, we find ourselves in a situation where channels that used to be able to handle a 10-year or 20-year event suddenly are seeing those events every 3 years or 5 years or 10 years. So big events are coming more frequently. Channels are changing. Communities have to manage them. And even before the levee breach, a plan was in place for the advancement of that project. They call it a Pájaro River Flood Risk Management Project. And that's this big federal state project to redesign, in some cases, shift levee locations, think about where they could be extended, think if there were other areas where they could be reoriented in some way, kind of a holistic look at the system. And that included the tributaries coming in from the north, Corralitos Creek and Salsipuedes Creek. They join the Pájaro River in the city of Watsonville, and then it proceeds out to the west and towards the ocean. So that whole project is really looking at the whole thing. And what had happened was I had been in touch with some of the folks who were involved even before that levee breach. The County of Santa Cruz, County of Monterey got together, and they created a joint powers agency called the Pájaro Regional Flood Management Agency. And the idea was to have one entity that could oversee, coordinate manage the grants, manage the contracts, work with the Army Corps to help advance that project. So they were in place, but they were getting going. And then we had the breach. And so really what it did is it helped to point out the need. It helped to accelerate a little bit of action, but those wheels were in motion. They were already working towards making this happen.
You've set the scene beautifully, and I want to break it down a little bit. You've mentioned things about sort of increased water flow, potentially due to these more frequent, more intense storms. You've talked about sediment filling in the levee. So let's break down kind of the scene and sort of like what we were aware of in the years leading up to the breach.
Right.
What were some of the problems that we knew about before this even all occurred? Can we break those things down?
Absolutely. I'll start, because this is the basis for the whole project. I'll start with flood risk.
Okay.
And this is super important because that's the Army Corps' mission, is to mitigate flood risk.
And that is to protect people and property, I imagine.
It is. It protects people. It protects property.
Yeah.
And there are other benefits, which when we get to the end here, we're going to bring that in. There's other benefits that come with managing floods. But for the primary focus of the project, it really is about managing that flood risk.
Okay.
And a large part of that is maintaining channel capacity. So what we're talking about here is if you have a certain amount of flow, is the channel big enough? Is it smooth enough? Does it have the right shape and geometry that it can handle those flows?
Ooh.
And, yeah.
So shape and geometry and the smoothness.
Yeah.
Can you tell us a little bit about the physics there?
Yeah, sure. In general, if you have a channel that's very rough on the inside, the water's trying to flow through, but you have a lot of vegetation. You have areas where the channel gets really narrow and then it suddenly widens out. If it takes hard turns, these things can slow down the flow, and that can cause water to back up. And if you have a really big event, that can make it harder for the levees to do their job. And at the extreme, it can even potentially increase the risk of a levee failure, which of course nobody wants. That's an uncontrolled flow out into the surrounding areas, into the towns, onto the farms, onto the businesses. Not a good situation. So the channels are dynamic. Before people put up a levee, the Pájaro River used to move around in the valley quite a bit. There's a lot of energy. It meanders. It carries sediment. It deposits sediment. It can erode sediment. And all of those are part of the natural operating system. But when you now have a community built right up against the river, those properties are at risk, the farms are at risk, the businesses are at risk, and we need to find a way to help the river to do what it wants to do. Let it work, let it do its job, but in a way that's compatible with the other uses, and in maintaining ecosystems, maintaining endemic species, maintaining the corridors that wildlife might use to move around through an area. Those characteristics are also important, and they also occur inside levees potentially, depending on what the channel looks like.
I'm no plumber, but I'm imagining like the pipes in my house, right? And wanting those pipes to be clean so the water can move through it. Make sure that there's not these hard bends in the wrong places so that you're not backing up your sink and all that. I mean, it sounds like a similar...
It is. It's very similar. And the challenge is, if this were the pipes in your house, imagine if, one day the pipes are big and then over time they're changing size and then there's a big event and suddenly they're smaller. Like imagine the pipes changing actively while you're trying to manage your water. And that's kind of what's going on. And that's happening on a range of timescales. Over decades, things are changing, but things can also change because of one event. And it's happening differently in different places along the river. So that's all been known. And really, that's the motivation for the Flood Risk Management Project. Again, that's the federal state project that was the basis for forming the Flood Management Agency, for developing plans to revise the levees. Like, this is the primary focus.
And this, it sounds like we've been aware of, or we had been aware of this risk for quite some time. And is that because other levees had breached elsewhere in the country, and so we were kind of more aware of this? Or you had mentioned maybe there had been some breaches along the Pájaro River in the past. I mean,
that's right. The year I was hired in 1995 was a big El Nino year where we had sort of wild weather in the wintertime. And there was a breach on the Pájaro River and there was flooding in parts of that area around the city of Watsonville, city of Pájaro. So this has happened before. And in addition, I had been talking to folks with the Flood Management Agency about the possibility that other benefits could be brought to the table. That while flood risk is reduced, it might be possible to improve habitat for desirable species, to reduce the presence of invasive species, to enhance groundwater recharge, because earlier work that we'd done about 20 years ago showed that as much as 20% of the recharge of the regional aquifers in the Pájaro Valley were occurring through the channel of the Pájaro River and Corralitos Creek, the primary tributary flowing in from the north. So, and also as water moves through a channel, some of that water goes in and out of the bed of the channel. And that can help with nutrient cycling, with removing undesirable compounds that are in the water, things like excess fertilizers or septic leachate or things like that. And so the question we'd been talking about for years was, well, could any of the improvements that might be made for flood risk reduction also give co-benefits for groundwater, for habitat, for water quality? Just to understand where the opportunities were so that when the changes went in, they could be done in such a way that you'd get the other benefits as well. Without having to compromise flood risk reduction, you could build in these other benefits. And the other key thing we wanted to help build in was ease the maintenance, because this has been an ongoing challenge that the locals typically have to take responsibility for maintaining that flood capacity. And this requires access points, places to stage equipment and supplies, understanding what needed to be done to different areas. There might be one area that's a hot spot for habitat. There might be another area that's a hot spot for water quality improvement or recharge. Can we identify those and then create designs or help give advice so that the experts, the engineers, can create designs that will allow it to just be more maintainable?
Cool.
Right, over time.
So I think what I'm gathering is the primary problem that we as a community saw was the flood risk. That's kind of where this all started. And then when you were starting to get involved, what you started seeing were opportunities to solve some other problems.
That's right.
Alongside the flood risk mitigation work.
And this idea was surfaced by the Flood Management Agency.
Okay.
We're really fortunate in this area. I think many of our resource managers, resource leaders are pretty creative. And they saw that this was an opportunity, or potentially, we didn't know. So part of the issue was understanding, how's the river functioning now? Where do we think these opportunities are? And then the other point is, many restoration projects are done without necessarily being able to show that an improvement was made.
Yeah, sure. The tracking and showing impact
it's really
is
hard.
so hard. Yeah.
It's really hard. Often with things like restorations after a fire, restorations after, again, a levee project, after a lot of kinds of environmental restoration, it's pretty common to lack the before data because you often don't know, and that motivation to collect all that information before isn't quite as strong right away. So I'd actually been in discussion with the director of the Flood Management Agency for a couple of years about, we were just kicking ideas around, like, wouldn't it be great if we could find some funding that would allow us to get this before data, sort of bank that data, get the information, set it all up in a format people can use, put spatial data into a geographic information system, a mapping system, make the measurements, have students do thesis work so that we can get 2-3 years of data. This is the other problem. It's pretty common to run out and grab just a set of data, a set of observations. And we call that like a synoptic sample, something where you get like a snapshot.
Yeah.
Like imagine you could just freeze it in time. What's there? The problem is the systems are dynamic. And so that one moment, you don't know what it means. Maybe you're catching it after a dry period. Maybe it was a really wet year and everything looks different. And indeed, we've been doing monitoring now for about 2 years, making measurements, doing experiments. And these 2 years have been wildly different. We really started at the end of 2023, which was quite a wet year, not a catastrophically wet year, but it did lead to the levee breach. It was higher than the average, but it wasn't as
Some
big or as
outlier.
95 or no, it wasn't a massive outlier. And then things got pretty dry the next year, and we really saw big differences the way the river operated in those 2 years. We're still doing a little monitoring, but the research project was really 2 years for what we call water year 24, water year 25. So about 24 months of fairly intensive monitoring. We had dozens of people involved at multiple institutions, collecting samples, setting up instruments that would continuously record things, sending out teams to make campaigns down the river to collect samples, measure the flow, collect sediment, find out which organisms were present. It's a multidisciplinary effort with collaborators in a bunch of places. Just as one quick example, in the first major year of the project, we were able to work with the Department of Water Resources to get their support in running surveys along the inside of the levee to make electrical measurements that would let us sort of visualize the upper 100 feet below the surface.
Cool.
Very cool to see what was the architecture of the geology. Why were certain areas better connected or not as well connected to the subsurface?
And why would that matter?
Well, because if you're trying to figure out where are the opportunities for recharge, where are the opportunities for surface water, groundwater interaction, for water to come in and out to make the water better, and for the Army Corps, where are the opportunities to acquire what they would call borrow material that they could use to reconstruct the new levees, because that could save millions of dollars through the construction process.
Borrow material meaning like where they could dig out dirt and replay and sort of move it somewhere else?
Because every truckload of earth that's available locally does not have to be brought over the hill on Highway 17 or come up the 101 to 129. Doesn't require Caltrans flagging to bring into the work sites. Like, there's a huge cost and complexity in bringing millions of acre feet of material or hundreds of thousands of acre feet, just an enormous amount of material to build kilometers of levees. And it has to be the right material, not too coarse, not too fine. So part of this mapping that we're doing is letting us visualize what kinds of sediments could be found in what locations.
Oh, super cool.
Now, however, it all came together at the last minute, and it wasn't possible for the work crews who normally clear those areas out to prepare for the surveys. So my students and I ran down to a tool shed and got a trailer and rented an industrial mower and a giant industrial side weed whacker and spent several days running up and down the river, clearing pathways through the weeds and the vegetation that had grown out inside the levee, in order that when the electrical survey crew came out, they could ride their ATV down there and drag the equipment along right next to the river. So we basically had to be like the cleanup crew to get it all set for them, which was an experience, something we didn't think we were going to have to do. But it was in the end, it was really interesting because it really made us look carefully at the sites, think hard about where we were, what were the best opportunities, where could we squeeze in multiple profiles, not just one, making us look and see. We've now been up and down that channel just dozens of times, in the channel, outside the channel, on the levees looking down, at the bottom of the levees looking up. And you get a different view of the system each time. It changes over time, and it's different in different locations. It's different on different sides of the river, and it's different upstream than it is downstream. And so through that process, we're able to acquire incredibly, incredibly valuable data that we otherwise would have no idea about.
And you kind of got forced into it.
It's what we had to get it done. We knew that this window had just opened for us.
Yeah, and you had to go.
We had to go.
A theme that keeps coming up on this show is the value and the power of these kind of long-term monitoring programs, because I think even I myself, I think about this, multi-decade in some cases monitoring. Yeah. It's kind of like, really? Are we what? Why? But one of the things I've learned is when you have that wealth of information, it can unlock funding and it can accelerate solutions that we all want. And absent those things, it makes it a harder case than sometimes to unlock that funding.
You're absolutely right. In oceanography, in hydrology, and let me be clear, it's not one or the other. It's one of our grand challenges is we need both. Yeah. We need intensive campaign style research, We need controlled experiments where we know what the perturbation is and we watch how a system responds. Like that is special for what it provides. And we need that context. Sometimes it's true, the monitoring can be fairly consistent and you don't necessarily see a lot of variability. Of course, you don't know what's going to happen the next month, the next year. So it's a challenge, in a world of limited time, limited staffing, limited funding, how we distribute this. But time and time again, we've seen in these dynamic systems, biological systems, hydrologic systems, oceanographic systems, these systems are changing. And if we're not able to, even if it's monitoring for a few months inside of which we do our campaign, right there, it provides you with so much more just because you know where you are on a cycle to understand what it is that you're measuring or sampling.
Your example of bringing the students out and getting the mowers out and clearing the path, I think to me that highlights one of the things I so deeply admire about you, which is that it seems to me at least that a lot of your science, a lot of the work that you're conducting is informed by and motivated by local solution making, and you're in touch with stakeholders, agencies, farm owners, landowners. You're talking to all of these people about these solutions, and that you're seemingly uncovering like win-wins for a lot of these people involved. And I know it's not perfectly balanced, but you've now mentioned a couple of sort of co-benefits here. You've talked about flood risk mitigation, groundwater recharge, habitat restoration. I kind of want to dig into each of those things one by one, and maybe starting with the flood risk mitigation. So when we think about what solutions might be on the table for that community, what does the levee rebuild look like, or what's the work going in there, and how does your science fit in?
Right. So there are several approaches that are helpful for flood risk reduction, right? I mean, mitigation can involve moving people out of the floodplain, for example. Yeah. So let's be clear, because there's many ways to approach these kinds of problems. And in fact, in some cases, historically, FEMA has bought out communities that are in particular risky areas. That's happened in the past.
In other words, FEMA comes in, they pay people to move out.
Yeah, properties get red tagged, or there are other incentives. It can be as straightforward as offering market value for property. In some cases, entire communities have just shifted their footprint. They've moved out of harm's way, or at least in a place where there's less frequent harm. At this point, that's not on the table for this community.
Yeah.
Really, the issue here is the lower Pájaro River is kind of at the receiving end of the entire watershed. And so water is being delivered. And the question there is, how do you lower those flow levels? The amount of water coming in, that's a hard thing to control. This is a function of climate, which is sort of long-term weather. It's a function of how intense the rainfall is and how much runoff you get. I mean, you can think about reducing our carbon footprint as a form of mitigation, but that's a form of long-term mitigation. Maybe that's something we'll come back to later.
Sure.
But in the shorter term, what we need to do is figure out how do we make these channels more capable of handling that water.
Got it.
So there's a couple of general ways you do that.
Okay.
One is to make them smoother if you get rid of the roughness. Another is to make them deeper or make the walls taller. You're increasing that cross section. It just allows more flow to move through.
And more volume. It can hold
Yeah.
more water.
And you can also take those levees and you can move them back sideways. Now, in the Pájaro Valley, if you were to move levees back from the river, you're now moving them onto, in most cases, privately held property. And so the Flood Management Agency is taking great care in working with community members, landowners, tenants, because a lot of times the farm land is leased for growers. A lot of the farming that's done in this area, very high value ag, organic crops, berries, conventional crops of a whole different range of kinds. The area is so productive. They get multiple plantings in a year for certain crops. It's just an amazingly bountiful area. And we see that. We see that in our local stores. We see it at the farmer's market. It's just amazing. You get used to it here, but you travel to other parts of the country, you realize how fortunate we are to have that kind of community here close to this part of the Central Coast. So So for all of that, there needs to be coordination, collaboration, figure out where are the opportunities. One approach that people sometimes talk about is sort of identifying the lower value land. That is the land that may not be as productive for a variety of reasons. It may be the soils aren't the best. It may be other characteristics. Of course, the challenge is in cases where you have different economic situations for the growers, different landowners. Often the lands that aren't the best producing also are those that are managed or leased by growers who don't have the economic resources that others do, right? So if you have disadvantaged communities, in some cases, you'll have those who can least afford to move who are working those lands.
Understood.
So we really have to be careful, as we think about how do those values get assessed and then what trade-offs are being made. But that's the work super important work that the Flood Management Agency, PERFMA, is doing. And again, they've been working on this for years. This is a process of identifying the properties, talking to landowners, talking to growers, figuring out where the opportunities are. Are there folks who get flooded so frequently that they're actually for them, it might be a good thing for that levee to get set back. So what happens when a levee gets set back is when a big flow comes in, it's allowed to spread. And that means the water level is lower, but it also slows the water down.
Literally the speed of the water moving down the channel.
Yeah. Exactly. Yeah. So, and it's interesting because early in the Army Corps' history, there was a lot of debate about the best way to protect against flooding, whether it's to help the water get through as fast as possible or whether it's to spread it out. There's a really cool book by John Barry. He wrote a book called The Great Influenza it made kind of a comeback hit during the COVID era because it talked about the flu during the early part of the 20th century. Before that, he wrote a really cool book called Rising Tide, and it's about flooding in the early 20th century along the Mississippi River and the city of New Orleans. And it talks about this development of a debate between engineers about should you make rivers wider or should you just make them smooth and straight and get the water through? And that debate is still going on. And it probably depends on where you are and what the conditions are. But there's lots of different ways to deal with this. In the case of the Pájaro Valley, it makes a lot of sense, if you can, to set the levees back, let the water spread. What you're going to do is you're now going to bring part of the floodplain inside the levees. You're going to essentially connect that part of the floodplain to the river again. Because
how does that work?
Well, you're allowing water when it's flowing in the channel and the flow gets high enough to spread. And of course, that's what it used to do. Some levees occur naturally.
Yeah.
And the levees that form naturally are occurring because at high flow, the water spreads laterally, and as it slows down, it deposits sediment along the edge of the channel. And it's really interesting. Hydrologists and geomorphologists, those who study the shape of the landscape, they've discovered that kind of the 1 to 2 year big event sort of defines the height of the natural levees in many river systems.
Oh, interesting.
Yeah. Apparently it's infrequent enough that it's a kind of a big event, but it's frequent enough that it can build up enough sediment. And so what you see is the channel full event is the one that defines kind of the natural levee system.
And so how does that knowledge factor into?
Yeah. Well, those natural levees are, again, they're going to be overflowed every 2 years or so.
Right.
Well, that's not enough. If you're farming that land or you have towns and schools and businesses, you can't really deal with flooding every 2 years.
Yeah.
Now, you might be able to if it's a park area, and you might be able to if it's a kind of farming that can come in and move out seasonally, right? Those kinds of activities are possible. But for more permanent farming, communities, housing, you really can't do that. And so that's why levees get built up, so they can help to retain the 50-year flood, the 100-year flood, the 500-year flood, whatever your target is. They're made bigger. And again, often what's done now is they're moved out. And in some cases, the Army Corps is actually being quite innovative in some areas. They built multiple sets of levees for different levels of flooding.
Oh, cool.
And you might have a nearby channel area, and then outside that, you might have an area that you allow to be inundated, but less frequently. And then outside of another set of levees, you might have your permanent communities, right? And so there's different ideas that are being developed, being tested, but you can imagine these get complicated when you're talking about established areas, farms, buildings, towns. There's a lot of complexity here.
You know, if you haven't visited the Seymour Marine Discovery Center at UC Santa Cruz in a while, or ever, you really should come visit us. We are right on the bluffs of the beautiful Monterey Bay, with an aquarium full of local species and a bunch of hands-on science exhibits that help you understand what's happening in our ocean and along our coast. We are connecting the incredible research happening at UC Santa Cruz with real-world solutions for our coastal community. We don't want science to just sit on a shelf. We want it to shape decisions, inspire kids, and help our community feel equipped to act. So if you care about the future of our ocean and our coastal community, or you just want to experience a place that makes you feel a little more connected to it, come visit us at the Seymour Marine Discovery Center. Science Solutions, Santa Cruz. Yeah, well, I mean, one thing going through my head is if I'm a landowner there and someone's coming to me saying, "Hey, we want to widen the levee. It's going to come onto your property." I mean, an immediate rational question would be like, "Well, what's in it for me?" Right?
Right.
So what's the answer to that?
There's a lot of options.
Okay.
And these are the kinds of things that are explored by PERFMA in managing this I mean, this is, again, the reason they exist is to manage this process and to do so in a way that's open and transparent and working with groups to try to balance a lot of these trade-offs.
Right.
So land can be purchased outright. There could be an easement, which is an access for flood control. So the property would still be owned, but part of it is separated with a levee, and perhaps the landowner and tenants have access to that area. But then when it floods, it needs to be allowed to flood. There's a lot of ways these sorts of things get managed, and it all has to fit together. You can't have a total patchwork where you have like, well, the levee, takes a left turn and goes around that property, and then it goes on the other side of that. It's not like like you could kind of do that with a highway, but you can't really do that with a levee. There's some continuity that you need.
And this goes back to just the physics of water flow and the sort of the home pipe analogy again of like, you can't have your water just like weaving and snaking through.
Yeah. Not when the flows are big.
Yeah. Okay.
Like you could try that, but you're going to get overwhelmed.
Yeah.
Because the power of these large flows, I was just looking today on the Pájaro River, the flow is about 50 cubic feet per second. And I don't know, think of that as, a few hundred milk jugs, every second.
Okay, that's
right.
helpful.
Kind of picture how much water that is. But at the big flows, when it was over 10,000 cubic feet per second during the breach in 2023, during the big El Nino in the 1980s or in 1995, you approached or exceeded 20,000 cubic feet per second. So just, it's hard to picture when you're standing there in the river now and you look. It's hard to picture what this thing is under high flows.
Sure.
It's just so different. It's hard to imagine it. So, this is something that we've sort of absorbed over time, seeing how these projects develop. My research is focused on these processes, the hydrogeology, how the water moves, the interactions. It's mostly technical in nature, but we've ended up getting involved in many cases with issues of community engagement, with permitting, with questions about land ownership, questions about rights of access, just because that's how we are able to do our scientific work. Without understanding these aspects, we just don't get access. We don't get to do the other part. And we really want our findings to be used. We'd like to see that knowledge transferred in a productive way. Not telling them you should do X, Y, and Z, but saying, hey, here are some things we learned. What do you think? Does this help to inform? And then do you have questions for us? Because we can run out and check that. Like if we know what you want to know, we might be able to provide you with that information that's actionable.
See, to me, Andy, this is why I love you, man. Like this to me is the sort of essence of science connected to solutions, and in this particular case, in a locally relevant issue, right?
Yeah.
I mean, the fact that you are at the table, not just like sharing your data, but listening to all the people who have a stake in it and their concerns and their questions informing the kind of research that you are undertaking.
Right.
I mean, to me, I feel like that is such a beautiful partnership.
Yeah. Part of what motivated me, getting back to what you asked about early on, part of what motivated me to kind of make this pivot years ago towards freshwater work was I still enjoy the oceanographic work, and it's interesting and it's fun. And in the long run, it has the potential to provide a whole variety of benefits, and we can talk about those. But I also really had this desire to get involved in work that I could see the impact soon. And it was something that students were interested in. You know, when they reach out either as undergrads or as grad students or even as postdocs, where folks are looking for opportunities, they often want to take on projects that are going to provide solutions to problems. And so that was an incentive to be involved in that. And I agree. When I am with these groups at a field trip or at a community meeting, it's inspiring. And that inspiration the glow of that kind of carries us along a little bit when things are challenging.
Well, so we were talking about the kind of the levee and the widening of the levee as one of the ways to reduce flood risk, because it allows sort of more water to move more slowly through, and which I think translates to less pressure on the levees,
so it
right?
does two things, right? And it sounds like we're saying two things that are in conflict, but they do go together. Getting the water out is one approach. Spreading the water, which allows bigger floods to be handled, is another approach. And there can be a combination. You can end up with, by clearing the channel out, maintaining it well, that can help to lower the roughness, which allows water to flow. And you can have targeted areas where it spreads and slows down. So you're actually able, if you're creative and willing to kind of look at a map and think about all the options, we can maybe do both. We can maybe help the flood wave move through quickly, and we can spread it out. We can also allow it to do other work within the between levee area.
And I understand that the designs are not final yet, but are both of these solutions being considered, or both of these approaches?
They are in play.
Okay.
They are in discussion.
Yeah, great.
And the idea that the way we deal with the roughness, ultimately, you could say, well, why don't you just go in and bulldoze out all of the trees or all of the vegetation? And one could do that, but you're probably going to be sacrificing a lot of habitat along the way. These rivers are corridors for wildlife, in many cases for species that were here already and maybe exist in only a few places. Over the years, the amount of habitat along the Pacific Flyway for migrating birds, for example, for butterflies, these areas of wetlands and the riparian near stream areas, they've been greatly reduced.
Yeah, I don't know. The number's crazy. It's like 90% or something.
Yeah. And so these areas are really hotspots for ecology, hotspots for habitat. And one of the questions that we asked early on and we're trying to advise on going forward is, what are those characteristics, those land values that are there now that could be continued or enhanced? What can we do without sacrificing key habitat? So the other issue is, once you've set the levees back, you're going to start with a relatively smooth profile. How do you maintain that?
Yeah, over time, sure.
Over time, because these costs can be high. Again, the communities, the counties, the cities, the towns, they're going to end up bearing that responsibility. The Army Corps typically is not going to be coming in to clear those out. And so one of the things we've been talking about with the Flood Management Agency is trying to design these new systems where you decide certain features are going to go in certain places. We'll have some particular habitat here. We'll have a side channel in another spot where water can come around near the levee, and that might allow more processing of nutrients that will clean up the water a little bit. Let's build in access points. Let's build in ramps. Let's build in places where you could stage equipment so that when you're going to do your annual or every 2-year or every 3-year cleanup, the crews have a place to mobilize. They can get everything set up. They can put a place where, if they're cutting vegetation, they have a place to move that for staging it so it can then be taken out. A place where the chippers might be set up. Again, it depends what they're going to do. And this sounds, sort of in some ways obvious, but it's not. Because if you don't know what that maintenance is going to be. What does that look like? And you don't think through, well, how many people will be involved? What kind of equipment? How much space do we need? What's the footprint? How often do you need a ramp? How much land is that going to occupy? If you end up moving the levees right to the edge of your property, well, then you've now removed any chance you have to build the ramp access. So again, it kind of sounds straightforward, and I guess in concept it is, but in practice, to really think ahead and build in all of these characteristics that you might want is going to take time. And we have to think ahead and also then reconcile that with the budget, with the time required to do it, with the personnel that it'll take. At what point do you engage with the maintenance folks in the design? That's not something you might normally do, but maybe this is a case where getting them on board at the table, let them say what occurs to them. Like when you think about it, what do you think about how that maintenance will be done? Again, I want to be clear. That's not our job to tell others how to do that. It's more of raising these issues so that hopefully in a constructive and positive way, folks will get together, right? Try to help create an environment where people are willing to do that.
Yeah, I can imagine, right? If there's like a multi-mile stretch where there's no ramp access, you can't get your excavators in, you can't get your whatever in. And so how the heck are you going to do the maintenance? Now you got to do human labor, and that's a whole thing. Right.
And if you let it go for too long, you may be prohibited from doing that maintenance because you may establish certain habitat.
Oh, fascinating.
Right? A wetland habitat for certain species that are protected. So as long as you're doing the maintenance, you're allowed to keep doing it. But if you stop, certain things can happen, which then make it harder to start again.
I mean, you're like, all of you involved in this, you're like threading this needle. I mean, it seems like this Venn diagram where you got, the economic needs and the farming needs, the agricultural needs, the flooding, the habitat, the water recharge, access, and budget, and you got to find what is the solution that
we're trying to help the folks who actually make the decisions to do this. That's exactly right.
Yeah.
And to touch on what you just mentioned, we think there's opportunity along the river where the levees are going to be set back to increase groundwater recharge.
Okay, what's this? What is that?
So that is where some of that river water can soak into the ground, go below the river, and eventually work its way into an aquifer that's being pumped for groundwater.
And an aquifer is?
An aquifer is a subsurface region where water can be stored and it's transmitted relatively easily. And if you put a well in the ground, you can pump water.
That's what we're sucking out of when we have these wells. And to be clear, this is not like a lake underground.
It's not a lake underground. It's mostly the tiny little spaces between grains of rock, between chunks of sediment or little bits of gravel. And those tiny little spaces, they add up to just enormous quantities of water, but it's all hidden. It's below the surface. And what that geology looks like is very different from what you might see just on the surface.
How so?
Well, you can have places on the surface where there's a whole lot of water, but under the ground, you might have a big layer of clay.
So why is groundwater recharge important?
Groundwater recharge is important in the Pájaro Valley in particular because more than 90% of the freshwater needs are satisfied by groundwater. And if all you did is pump water out and no water went back in, then it would be like a trust fund that you're depleting without another input. There is recharge occurring. It's occurring around the edges of the valley. It occurs upstream from the main area that we're working on, where the bottom of the channel appears to be in good connection quite directly with an important aquifer. But as we move into the area where the levee setback is being considered, that area is separated from the aquifer except in a few special places.
Fascinating. So you can't just expect water coming down the levee to soak in everywhere.
That's right. In many, many places, when things are dry and those first flows come down, those flows will scour the channel a little bit. They'll pick up some of the fines. They'll take it away. The water will soak in, but the available space is limited. And what's right below the river is kind of a thin, sandy unit. It fills pretty quickly. And once that's full, there's just nowhere for the water to go.
So it stays at the surface and flows out.
And we've measured that. We've measured that there's a period of time each year. It's kind of, we see it especially at the end of the rainy season and at the start of the rainy season, where the channel's kind of just right and we can see loss occurring. And it's modest. It's not a huge amount, but then it shuts off later on in the year. So it's a dynamic thing. You don't see it all the time. Upstream, we see it all the time. Upstream from this 8-kilometer reach where the levees are being considered, where we're really working on the designs, it appears to occur year round. And that could supply something like 10 to 15% of the recharge for the whole valley.
Just what's happening upstream.
Yeah, upstream in that section of the river.
And if we get it right with the levee, I mean, what kind of percentage are we talking about in terms of at best case scenario?
Yeah, possibly upper single digits,
Okay.
maybe above 10%. But
Okay.
it's a piece.
Yeah.
It's a piece.
Yeah.
But the way to think about it is it's a piece that we could get with relatively minimal effort going forward.
Compared to some of the other...
Compared to other options.
Yeah, got it.
There is recharge occurring. It's not that this is the only place it occurs, but this is kind of a window of opportunity.
This is low-hanging fruit.
Yeah.
Yeah.
If we can help that happen and reduce flood risk and improve water quality, because in addition to getting groundwater in, there's water in the river that goes in and out of the stream bed. It goes in and out of the riverbed as it flows downstream. And that's an environment where microbes can help to consume some of the nutrients and remove them from the aquatic system. It also will be good for habitat because you're gonna increase the water availability for vegetation along that corridor, and that provides shade, which is really important in the summertime so the water doesn't get too hot. Some of our colleagues at Cal State Monterey Bay have been looking at environmental DNA in the river to see who lives where. They've identified places where they see evidence of steelhead, so they know that this is still potentially viable as fish habitat. We knew that there are fish up Corralitos Creek. That's known to be an important creek. But in the Pájaro River, it's encouraging that they see environmental DNA in the stream channel. It suggests fish are migrating up there. Again, you might not see them every day, but if we can help to increase that habitat value, then that might help the fish runs over the long term. Yeah, you can get these benefits and they build on each other because a more resilient river is also a river that has lower flood risk, and it helps the rest of the valley to be better, to have more water, to have more habitat, to have higher water quality.
I got to get someone from UCSC to come on and talk about eDNA because that's like it's amazing technology.
It's amazing
yeah.
You can sample and then get kind of a catalog of who passed through or who's there.
So, I'm so excited about this work because of the potential benefits in so many different ways, right? For so many different people. And I think it's just an incredible example of science connecting to real world solutions that are solving real problems in the community. It's incredibly complex, right? I mean, there's all these stakeholders. Where are we now, like in terms of these solutions being rolled out, let's say,
Yeah.
and what should we expect over the next couple of years?
Right. There's a number of groups that are pushing these ideas. We are certainly not the first. Within the Army Corps, there's a group called Engineering with Nature. And our primary contact in the San Francisco region office of the Army Corps is part of that Engineering with Nature effort. And that group, which is a national group, have identified 5 proving grounds for this concept of combining benefits. And one of them is the Pájaro River.
Okay, amazing.
So again, a confluence of opportunity. They had identified that years ago. Okay, and they're working all over the country. Again, smart people, motivated, trying to figure out how to get more bang for the effort, more benefit for the same amount of money. What's going to convince people is showing the results.
Going back to that monitoring.
At the end of the day, yeah. And the results need to be cost, permitting, like is it easier to permit or at least no harder to permit when you involve all these other groups? That may sound obvious, but it's not. When there's habitat involved, things can get complicated. Community buy-in. This is a potential source of friction. Does this help? Does it hurt? Improving water supplies, improving water quality. When you look at all these different parts, we want to show that it's real. We want to quantify those benefits. And that'll take a little time. I like to think of what we're doing as setting this foundation. So the most important thing we can do is demonstrate the effectiveness. And that's going to come by data collection before, maybe some during construction, we don't know yet, and then some data collection that'll come after. And we may be involved, others will probably be involved. We'll see. We'll see how long it takes. But this might be in the end a 10-year, a 20-year effort.
Well, Andy, I've got a lightning round of questions for you, but before I get to that to close out today, is there anything that we've missed today that you make sure you want everybody listening to know about Pájaro River and the work that's going on there, or anything else related to what we've talked about today?
I think one thing I'd mention, and we sort of touched on it a little bit, but what I've been really impressed with in this project with the river and in other projects, I am very impressed with the quality, the creativity, the energy brought by all of these groups, from water agencies to growers to advocacy groups to the RCDs, who are really bringing ideas to bear. They're willing to sit at a table and consider a whole variety of perspectives and ideas. They're really trying to do the good work. I know their job is hard, and I know it's difficult to communicate all that they do.
We'll provide some links in the show notes here so people can kind of keep up to date with what's going on. And
that's great.
Find opportunities to share their gratitude or their dissent. Either way, right? Either way, it's important. So, all right, Andy, quick round of lightning round questions for you. Are you ready?
Yeah, we're ready.
Okay. If you weren't doing this job, what would your alternate reality career be?
Yeah, that's a good question. For some years, I went to and then I worked at this crazy, amazing summer camp in Maine, and I learned and taught ceramics and other summer campy things. And I don't think I really entertained it too seriously, but I had a big pivot in grad school where I had to stop working at that camp, and it was hard. It was hard because I sort of feel like I really grew up there, and something where I could be creative and work with people. I don't know what it would be. I don't know, but because I kind of stumbled into this, but I guess maybe something with ceramics or a summer.
Well, we're going into summer. I have a 6-year-old, so shout out to all the camp counselors out there, because this is so great. It's important work.
It's important.
All right, question 2. What's the best piece of advice you've ever received from a mentor?
My primary advisor as a grad student, Keir Becker at University of Miami, shout out to a remarkable scientist and human being who mostly advised me by example. And I think what I learned from them is do the work. They did their homework. They were ready. They listened. They weren't bombastic. They nurtured community. They took care of their professional relationships, treated people well. And I think by osmosis and observation, that's the advice I got from them. I don't remember anybody telling me those things, but I remember looking around at the people I admired, and that's what they did.
Well, Andy, from the outside looking in, it seems to me that you are paying that forward with your students
I hope
here.
So.
Yeah, it really does.
Hope so.
Question 3, what's your favorite outdoor spot for a quick hit of nature?
I'm fortunate to live not too far away from here. I live a couple of miles away. And I'll tell you, just walking along the ocean here, whether it's one of the beaches or West Cliff Drive, is always worth looking at. And you never know what you're going to see. And whether it's just the simple beauty of looking down at a flight of pelicans skimming along the water, or the birds diving on the ocean, or the color and shape of the waves, whatever it is, it's just always interesting. So it's remarkable that we have this right here and can get that little charge when we need it. Just a quick walk along the water. It's the best.
What's one book, movie, show that you would recommend to fans of this show, Science Solution Santa Cruz?
There is a really cool book that came out just a couple of years ago called The Dreamt Land. And it was written by Mark Arax, A-R-A-X. It's kind of a follow-up in some ways to Cadillac Desert, a book about water in the West. It's a modern update, and it's a lot about how we ended up with this wild agricultural water system we have here in California, from the perspective of a journalist, he's a great writer, and from a family of growers, of farmers. It's a beautiful book, and it's super interesting, sort of telling that story.
A Dreamt Land.
The Dreamt Land.
Okay, last one for you, Andy. What gives you the most environmental hope right now?
There's a lot of things I think that give me hope. But I'll tell you, here's a quick story. I got to go to New Zealand a few years ago on sabbatical, and I visited this restoration project outside of Wellington, the capital city. Wellington's kind of like a mini San Francisco in many, many ways. It's cosmopolitan, it's hilly, it's interesting, it's compact. Outside, there's a private group that acquired a bunch of land. They're in the process of trying to eject all of the non-native mammals, which is all of them, essentially, because even people are kind of newcomers to that island. They built complicated fencing to keep out all the invasive mice and rats and stoats and possums and so forth, allowing the birds to come back. The birds are already coming back. It's a crazy place to visit at night. You can take tours, and the bird sounds are wild in New Zealand. The birds are crazy. When you walk in, you go through kind of this airlock and you brush yourself off and you make sure you're not bringing anything in, and you go through this gate and you get inside, and there's a sign that says, this is going to take 500 years. And I remember the first time I saw it, just the hair on my neck stood up. I couldn't believe it. It was so humble and ambitious at the same time, acknowledging how hard it is to undo these impacts and yet showing the commitment to doing it. And I think it gets back to what you were asking about the short term, the long term. We need both. We need the short term encouragement. We need to see some results. We need to know they're going to work. In the short term, we've got to do that. And we need to recognize that this is a long-term project, that if we're going to establish an equilibrium, a sustainable interaction with our environment, with these human natural systems which are surrounding us right now, it's going to take a while. That is not a reason not to do it. It's a reason to do it. And it does give me hope. I realize it's hard, but you go to a place like that, they've only been working on the restoration for about a decade, and already the plants and birds that have come back are astonishing. It's hard, but we can do it.
That's beautiful. I would absolutely love to visit someday. I mean, that's an incredible story. Well, Andy, really, truly a pleasure having you here today. I hope we can do it again sometime, but thank you so much for coming in.
No, thank you for inviting me, and you're welcome.
All right, that does it for the pod. Thank you, Andy, for coming on today's program. Thank you to everybody who is working to improve the Pájaro River levee and everything that goes into that project. Thank you to Edith Belmont for editing. Thank you to Cassidy Beach for production. Thank you to Valerie Situ for distribution and socials. Thank you for listening. And please do hit that like and subscribe button, make a comment, share with your friends so that we can get this program in front of more people in our community. We'll see you next time.